Now we're going to multiply radicals. I don't know what that 3b stands for. So let's take some notes on multiplying like radicals. So let's say that we have something like square root 7 times square root, I don't know, 8. Okay? So if I'm going to multiply these, as long as they're both under the radicals, what's under the radicals gets multiplied, what's outside the radicals gets multiplied. So this is just going to give me, now I would never write this step again, but it's 7 times 8, which is the square root of 56. Okay, but we never want to leave it like that. It's just like fractions. You always want them in lowest terms. So we're going to get this in simplest form. So again, refer to your list of perfect squares, back 2 pages. We want to find a perfect square that goes in 56. Again, try not to use your square button on your calculator so that you'll be stronger in how to simplify these. So it's just kind of fun. You can still use your calculator, just don't use the square root button. So I'm going to break into perfect square and non-perfect square. Perfect square and 56. So what I mean by this is I can take 56 and start dividing it by perfect squares. So does 4 go into it? Yes, it does 14 times, okay? But I'm not going to use the square root button. Don't use that, so you have to simplify. So 4 and 14. So I break it down into 4 and 14. That gives me 2 square root 14, okay? Now 14 doesn't have any perfect squares. The only thing that goes into it are 2 and 7. So that would be my answer. So square root 7 times square root 8 is 2 square root 14 when you're all done and you simplified it, okay? Now let's say that we have 3 square root 6 times 5 square root, oh, I don't know, 8, 9. That works, okay? So what we have to do here is we need to realize anything on the outside we can multiply. I can multiply those two and get 15. And I can multiply anything on the inside, and I get 54, okay? But these two, 5 and 9, can't multiply because the 9 is underneath. Oh, that's stupid. That was a dumb problem because, look, 9's a perfect square. Okay, I should not make these up on the fly. Anyway, you get the idea. That's what we're trying for here. So the 15 comes down. Then we're going to see if there's a perfect square in 54. Any ideas? Hello? Okay, so 9 times 6. Dumb problem on my part. Okay, so then I take, whoops. Sorry. I'm so flustered that I did a horrible problem. That's okay. We get the idea. Okay, so now the square root of 9 is 3, and then I have square root 6 left over. So it's 45 square root 6. Okay? So, sorry, silly problem. Let's go to ones that they've made up. And let's just start looking at some of theirs. Okay? Oh, wait, hold on. Let's refresh our memory on variables. If I have the square root of x cubed y to the 5th z to the 4th. Okay? Remember that when you have variables underneath, to find the perfect square of a variable, you have to have an even exponent. So if I'm talking perfect squares of variables, okay, perfect squares of a variable is you have to have an even exponent. Okay? So, if I break this into perfect square, non-perfect square, x squared, that's my closest even exponent to 3, so I have an x left over. Y to the 4th, I have a y left over. Because remember, when I multiply, I add my exponents, so I'm dividing 3 minus 2 is going to be 1. 5 minus 4 is going to be 1. Perfect square z to the 4th, that one is a perfect square because it already has an even exponent. So I take the square root of x squared by dividing the exponent by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. 4 divided by 2 is 2. So if I have variables, okay, I need to pay attention there. I'm going to break it down into even exponent, non-even exponent. And it's going to always be, but this is going to have an exponent of 1 over here with squares. Okay? When you get into other things, it won't. Okay, let's just do some quick ones. We did evens last time. Do we want to do evens or odds? Oh, we want to do evens so that you get to have more, because we want more practice for you. Okay, so here we go. Square root of. So I have a 10 and an 8. I'm going to multiply, get the square root of 80. Now I want to break 80 into perfect square, non-perfect square. What's a perfect square in 80? Now this I don't mind you use your calculator for. Just don't use the square root button. Okay, so I'm going to take 80, and I'm going to look at my perfect square. Well, 4 goes into it, and that gives me 20. That's a pretty big number. I'm going to try 16. So 80 divided by 16 gives me 5. So I'm going to break it into 16 and 5. Okay? And therefore, I get 4 square root 5. Okay? Good. Number 4. I'm going to multiply 6 times 5, and I get 30. Perfect squares that go into 30. Okay, well, 4 doesn't go into it. Does 9 go into it? No. Does 16? No. Does 25? No. Hey, we're done. That's it. It doesn't simplify. Okay, here we go. 18 times 21. I'm going to use my calculator. 18 times 21. This is legit to use your calculator. Don't use the square root button. So we have a 378. Now we want to break that down into perfect square and non-perfect square. Okay, so this is where we might go a little bigger. 4 goes into it, but let's start there. 378 divided by 4 gives me, oh my gosh, it doesn't go into it. That's surprising. Okay, so don't use 4. 378 divided by 9 gives me 42. 9 and 42, but let's look at 42. What goes into 42? 6 and 7. I don't think there's anything more. 6 and 7 aren't going to work for you. 3 and 14, that's it. So we get 3 square root 42. Okay? Let's jump down. Big number. Oh, that's not a bad one. No, let's go down here. Oh, yeah, because we have numbers on the outside. That's way more fun. So negative 4 times 7. Remember, if it's on the outside, I multiply it. So I get a negative 28. And if it's on the inside, okay, now that's kind of a stupid one because that's a perfect square. Don't worry. Okay, just play along. 4 times 12 is going to give me 48. Okay, now I'm going to break it into, negative 28 hangs out. I'm out of space. I'm going to go down here. Negative 28. Now I'm going to break it into perfect square, non-perfect square. 48 divided by 4 is 12. But hold on. Does 48, because look, what I do is I'm like, hey, that 12 has more numbers in it. 4 goes into it. So let's try 16. Take 48 divided by 16. And we get 3. Okay, so we get negative 28 times 4, square root 3. So that's going to give me 28 times 4. It's going to give me negative 112, square root 3. Good. Oh, yay. We go. Oh, hey, this one's a cool one. Look, you have square root 18 times square root 18. Well, wouldn't that just be the square root of 18 squared? And if I have a square root squared, doesn't that just give me what's the inside? Yeah, they were trying to trick us. We're too smart for that. Okay, look at this next one. We're going to multiply. We get 5 on the outside. On the inside, hey, we have 2 6s. Do y'all mind if I just leave it as 6 squared? Okay, no? Then let's write it as 36. Okay, it'll work itself out. And then I take x to the third times x to the third. When I multiply like bases, what do I do with my exponents? That's right, I add them. So 3 plus 3 is 6. Hey, everything under there is a perfect square. So that's going to give me 5. Square root of 36 is 6. Square root of x to the 6th is x cubed, because I always take the exponent and divide by 2. That gives me 30x cubed. Woohoo! Okay, here we go. Wow, there's so many good ones, I can't decide. Let's just do them all. So we're going to take 28 times 20. That gives us square root of 560 n to the 4th. Now we get to break down 560. Let's try 560. Let's try 4. Okay, let's try 16. Yeah, look at that. See, what you do is you just keep trying. Okay, so I'm going to break it down into 16. Left over is 35. N to the 4th, that's an even exponent, so that just comes over. So I get 4. And for variables, remember, you take the exponent and divide by 2, so that's n squared. 35, look at that. What goes into it? 5 and 7. Yep, nothing. That's my answer. Okay, good. I want to do them all. Okay, so I'm going to do 20. I'm just going to cram it in there. So 30, oh, that negative 6 stays on the outside. I'm just going to go here. Negative 6. Look at that big number. We're going to have 28 times 35. That's times 35. That gave us 980. R to the, when I multiply, I add my exponents, so R to the 5th. Hey, I kind of forgot a 0 there. 980 R to the 5th. Okay, the 6 just keeps hanging out on the outside. Now we're going to break it into perfect square and non-perfect square. We have to find a perfect square in 980. Let's try some stuff. What do you want to try? I'm going to try 16. Nope. 980 divided by 4 gives me 245. Hey, 980. 25 doesn't go into it. Does 9 go into it? 980 divided by 9. Nope. So 4 is the best we've got. Let's look at 245, though. We're sure there's nothing there. Well, it can be divisible by 5, and sometimes I could, look at what happens. I was wondering. So 245, I knew was divisible by 5. So I divided by 5 and got 49. They were trying to hide a perfect square on us. Okay? That's where they do weird things sometimes. So just to let you know, so I'm going to break it down again, or I can go back and take 4 times 49. Nah, I'm not going to. So I'm going to break it into 49, because I was just curious about that. Okay, and then I have a leftover 5. Okay, let me go through this again. So I took 980, I divided it on my calculator by 4, and I got 245. Then I was a little suspicious of that 245, and I tried something like 9, dividing it by 9. Nope, it gave me a decimal. So then I was like, well, I know 245 is divisible by 5, so I'm going to do that, and there it is. Like I said, they hid one. So that's where the square root 49 comes up. And then I have a 5 left over. Oh, I forgot to deal with the r. Okay, the r, okay, so we're going to simplify that. The r is to the odd power, so I have to get it to an even power. That's a 4, so that means I have an r left over. So this is going to give me negative 6 times 2r squared times 7. Square root of 4 is 2, r to the 4th is 2nd, square root of 49 is 7, and I get 5r. So I multiply all that together. 42 times 2 is an 84, negative 84, r to the 2nd, square root 5r. Okay, that's my final answer. Good. Ooh, which one do I want? Do I want 22 or 24? Let's do both. Okay. So here we go. This is going to give me square root of 350 a to the 5th. Oops, it's to the 5th power, doesn't look like it. So a to the 5th power. Okay, so 350, play with that one. What should we try? Oh, 25. Yeah, whenever it ends in a 0, I always try 25. So I'm going to break this into square root 25, and then left over is 14. A to the 4th and an a. So the square root of 25 is 5. Square root of a squared, sorry, a to the 4th is a squared. And then I have a leftover 14a. Good. 24, we have plenty of room for it. We can do the whole thing and not worry about it. So go, and if you want to, again, pause yours. 20 times 100 is 200. X times x to the 3rd is x to the 4th. So now I'm, square root of all that. So now I'm going to do perfect square, non-perfect square. Well, what's a perfect square? 200. That's right. It's 100. Okay, and I have a 2 left over. X to the 4th is a perfect square. Wow, that one was fun. Square root of 100 is 10. Square root of x to the 4th. Just take the exponent and divide by 2. And there we have it. Good. You can probably guess what your homework is. Ta-da! Good. Thank you. If you have questions, you know where to find us.